So you've looked at circle properties. Now let's look at how easy the questions are when you know the properties. So 80, what's the relationship? Half of 80, A is 40. A here, double 50 is 100. A here, 90, standing on the arc of the diameter. And you'd write that angle standing on the arc if you needed to. A, half of 110 is 55. So again, geometry becoming visual. And this might look a bit awkward, but here's the arc. This angle 66 and this angle A are standing on the same arc that you can see. They both leave the same point. So A is 33. There is another way to do it. If you wanted to do it a long way, you can maybe join these two together. This here is going to get 90. That's going to be 90 because it's standing on the same arc. That one's 90. This part of the 90, well, because this is a radius and this is a radius, 180 minus 66 is 120, 114, and if we divide that by 2, we'll get the two corner angles here. That's going to give me 57. So I don't have 90 in this little guy here. It's 90 minus 57, which is 33 degrees. And this guy here, this guy 114, 114. So 33 and 114 is 147, which would leave 33 degrees to get the third angle A, just a little bit elongated. So the last one here, you can see they're standing on the same arc here and here. So I have my 80 and I have my external A has to be 40. Okay, what's next here? Find the measure of the angle labeled in the following diagrams. It shows as much work as possible. Well, this angle here, we're told is 260, so the one here, I'll call it O because it says O there. O is equal to, well, the whole thing is 360, so O is 100. So A, it has to show the work 100 divided by 2, which is 50. Second question, if you turn your copy upside down, you'll see that it's standing the internal one and the external one. So we've got my A is going to be, so this one here is 360 minus 80, 280. So A has to be half of that, 280 over 2, which is 140. And down to part C. Well, A, these are standing on the same arc, so A has to be 34 here. A and 34 are going to be the same. So A is going to be 34. And what you write is angle standing on the same arc, and then B has to be 56. Same reason, angle standing on the same arc. This one here, A has to be 41, again, angle standing on the same arc. And B would have to be 82, double A. So A and B, 41 and 82. In E, we have B has to be 25, it's standing on the same arc, so B is 25. And A is double 25, A is 50. Now down to number 3. Find the value of the angles of A and B in the following diagrams. Okay, well, this one here is going to be twice the 110. So A is 220 and B has to be equal to 360 minus 220, which is 140. Second part of 3. So now we have a cyclic quadrilateral here. So opposite sides equal 180. So A is equal to 180 minus 36, which is 144. And B and 107 make up 180. B is equal to 180 minus 107, which is 73. So your cyclic quadrilateral. In this question, we can get this one straight away to be 102. 102. So B is equal to 360 minus 102, which is 258 degrees, and then A would have to be half of that. A is 258 over 2, which is equal to 12129. Put your symbols in. Cyclic quadrilateral again, and we have a straight line down here. So A is equal to 180 minus 104, which is 76. So B, cyclic quadrilateral, they add to 180. 180 minus 76 is 104 degrees. And then finally in part E, we have A has to be 48. It's standing on the same arc. So we have A here, this one, and this one are standing on the same arc. A is 48. And if we create a cyclic, I leave A is 48, sorry, A is 48, we create a cyclic quadrilateral here. For B, we have 1, 2, 3, 4. So A plus B is equal to 180. So B is 180 minus 48, which is 132 degrees. And I'll get 4 done in this video as well. Identify which of the following quadrilaterals could be inscribed in a circle. This one could. Yes, 130 plus 50. This one, 80 and 90 is 170, so no. And this one here, again, 120 and 50, 70, so no. So we have a yes, a no, and a no.